Welcome to ToKCast, where we're back for a second episode devoted to probability, and the fourth episode in my series on rationality by Professor Steven Pinker. In the last episode of ToKCast, I mentioned that I now have a newsletter. That's episode 112, I guess it will appear in feeds. You can sign up to my newsletter on Substack. So it should be somewhere there in YouTube, and what I'm intending on using that Substack newsletter for, because it will contain audio, is just a place to have some musings about things that I don't think really might fit with the theme of the usual podcasts. And so it might be updates on what's coming up on the podcast, or just reflections on things that might be more timely. Here on the podcast, I like to deal with timeless matters, things that can be applied no matter when and where you happen to pick up this podcast. But in the last main episode of ToKCast, that'll be episode 111, I turned to explaining what probability is and how it's used and misused by providing, at the heart of the episode, an explanation, in my words, of our best understanding of reality as it is, given what we know about the laws of physics. Following David's talk on all of that, now that episode generated quite a bit of a response, which I kind of expected, and so I tweeted a couple of things alluding to probability, and that also generated a lot of responses. Probability, it seems, like interpretations of quantum theory, like climate change, politics, morality, religion, UFO sightings, educating children, add probability to the list of third rail topics that, for some people, become very emotional, which kind of makes things fun. It is one of those things people were taught in school, probability. It's right there in the mathematics curriculum in most jurisdictions that I'm aware of. Kids learn it, and some learn it reasonably well. Some go on to specialise in fields which touch on probability. Some are paid for their forecasting, or couched in terms of probability. So a lot rests on what is said about probability. Again, like religion or morality or politics, things that seem to be largely a matter of opinion, probability is part of our language, and so people cannot see why a statement like, "It will probably rain today," when taken super seriously, literally, as a description of reality, "It will probably rain today," that statement, it's actually meaningless. In the case of that very example, "It will probably rain today." By the time the day is over, you'll know whether it rained or not. You will not observe that it had probably rained. If you observed anything relevant at all, either it rained or it did not rain. It did not probably rain. It never probably rains. But in any case, it's there in our language, and people speak English and other languages, and if you're using the word probably and associated words like likely or almost certain and so on, you know what they mean. So how dare anyone come along and suggest that you're speaking literal nonsense? Well, there's no perfectly precise language, so we're not saying you can't use the words and that one's use of language is nonsense, only that considering probability to be a true explanation of what happens in physical reality is just not true. But being there in the language, it's there in our minds in a deep way. There is some really interesting ways in which it seems like the meme itself makes strides at entrenching itself into our thinking and our culture. Of course, it's kind of silly to say the meme kind of has this desire. The meme, of course, the idea has no will of its own, but it really does get into people's heads, so to speak, so they'll defend it. Like the religious aren't content rather often to simply hear one out about their lack of religious belief. They want to convince you, they want to convert you, they want to show how you're wrong. Not all religious people are like this. Some are, but then so are some atheists. They need you to agree. So too with probability. Since last episode, I've been asked online and offline in Zoom calls and cafe conversations about genuine randomness versus things that obey the probability calculus. What we said last time was that nothing in reality strictly obeyed the probability calculus. Truly fair coins, for example, they're idealizations. And you'd need a truly fair coin and a truly fair way of tossing a truly fair coin and so on for it to obey the probability calculus strictly. But if we take the idealization seriously for a moment as a mathematical object, obeying imaginary laws of physics in abstract space, then we can use the probability calculus to model such an object, like a game. We can simulate all of this using a computer. It's just important to keep in mind that virtual ideal coins and dice and so on do not exist in our universe. In our universe, they're made of atoms that obey quantum theory, not probability theory. And those things are not identical, quantum theory and probability theory. But for now, we can imagine coins in let's say, the Star Wars universe. In the Star Wars universe, maybe there's imaginary coins there, coins that exist in the Star Wars universe, that do obey the probability calculus. Like the Star Wars universe has psychic forces, magic, and faster-than-light travel, and all sorts of other non-relativistic effects and violations of conservation laws, so let them have fair coins as well. In that case, in that universe, the coin, when it's flipped, really does land 50% heads and 50% tails. Half the time it's heads, half the time it's tails. Now, whether that means every second coin toss is a head, or it means that in the long run of like 100, you'd get exactly 50 heads and 50 tails, but maybe you wouldn't know the precise order until you get down to the last few throws. This all gets very complicated. I don't know. I'm not an expert in Star Wars physics or how laws of physics that allow for perfectly fair coins would work precisely. But whatever. In such a universe, I assert that what we would have there would fit the meaning of the word stochastic, which is a kind of randomness. So inherent in the universe there, Star Wars, the universe far, far away, are processes perfectly well captured by the probability calculus. Because whatever the deeper fundamental laws of physics are, they are allowing for perfectly fair coins and fair tosses and so on. A process captured by the probability calculus is stochastic by definition. They mutually define one another. It's a form of randomness. But I've argued it's not complete randomness. Ask a child what complete randomness would be if they were to flip a coin. My idea of complete and utter randomness, and to be honest, this is not mine, this is what we might call common sense randomness. It assumes no further axioms. Genuine randomness is something that won't even obey the probability calculus. So simply because it obeys some law, the stochastic law, well, it's not utterly random. Utter randomness, my example was a coin that when flipped really did do something random. It wasn't just unpredictable whether it landed heads or tails, but it was unpredictable whether it landed at all. Perhaps it violated conservation of energy and became a 10-ton lump of metal and violated the prohibition on the spontaneous generation of knowledge and assembled itself into a perfectly engineered great eagle, able to fly, and then violated relativity and various other conservation laws by accelerating to beyond the speed of light. Now that coin toss truly is random and not even governed by the probability calculus. So in that case, we can kind of have two sorts of randomness, I guess. Stochastic randomness and actual randomness. Actual randomness is just random. To get to stochastic randomness, you need to add some lawfulness axiom to it. Namely, you have to add the constraint. The system obeys the probability calculus, so the coin cannot violate other laws of physics. I should add at this point, the probability calculus, mainstream probability, predicts the coin lands heads or tails when you flip it. But actual quantum theory, it predicts heads or tails, plus also the other non-zero possibilities of it not landing at all but turning into a butterfly and flying away. Now, if you're rolling your eyes right now, I don't have time to go into all the details here, but let's just say that quantum physics is an explanation even of the small measure of universes where the absurd happens. Howsoever rare that happens to be. One should not expect this will ever happen to you, and for all intents and purposes, can be ignored in day-to-day life and decision-making, but it cannot be ignored by those who are committed, very strictly, to realism, rationality, good explanations, and of course, making progress. Consult page 300 of The Beginning of Infinity for more on this exact point about coins turning into butterflies, or rather, as David explains there, kettles of water turning into bunnies and top hats and then hopping away. So this is an important point I need to emphasize from last episode before we proceed. Physical reality is governed by the laws of quantum theory, among other laws. Applying those laws to coin tosses in a very hand-waving, but nonetheless consistent manner, we can predict that close to 50% of the time we will get heads and close to 50% tails. But it is inconsistent with saying that either of those can be predicted to be exactly 50%, because in the real world, flipped coins do not necessarily land heads or tails. They land heads or tails, or they do something else. That something else they do is physical, it is real, it can happen. And so if we want an actual rational conception of reality, we need to include that. The coin may land on its edge, neither head or tail. It may also, as we say, transform itself into something else. It does not matter how rarely, but it does mean that ultimately in the long run, as the frequentist wants, the in-the-limit approach, so to speak, to an infinite number of coin tosses, then we will indeed have a column that is other. Heads, tails, and other. And that will mean that heads and tails, when summed together, will always be less than 100% of the flips in the long run, according to quantum theory. Heads will be less than 50% and tails will be less than 50%. In the infinite sequence governed by actual quantum laws of physics, there is that third column, reducing both the heads and the tails, because sometimes it's doing something else. So this episode is very much going to draw on the last episode of ToKCast, number 111 in other words, based on the work of David Deutsch there. And we'll be applying literal realism and rationality to the next chapter of Pinker's book, Rationality. Now, in preparation for today's summary and reflections, I was watching some of what Professor Pinker has said during interviews on the topic of probability. For example, here on the screen is an image of the lecture I was watching. Anyway, and I'll put the link in the description. Anyways, there, Pinker makes some claims I found rather startling in light of, well, my close reading of his book. One such claim there is at the, it's at the 368 second mark. And he says there that formal logic is, quote,
and that's another reason why logic in the formal sense is often kind of useless for everyday reasoning. So game is an example, and vegetable. Now, of course, there are domains of thinking in which we do have to stipulate rules and ascertain whether a fuzzy category fits the definition.
Now, you see, I agree with that. So what's my problem? Well, my problem is that he has a book on rationality where he devotes an entire chapter basically to explaining aspects of it. Formal logic, rules of inference, truth tables, and so on. He even says on page 87, and let me quote, he says, quote, "The habit of formal reconstruction, even if carried out part way, can often expose fallacious inferences and unstated premises which would otherwise lie hidden in any argument and is well worth cultivating." End quote. So formal reconstruction, which is absolutely a part of formal logic, turning an argument into formal logic is what it is, he says is well worth cultivating. Now, in my episode of ToKCast where I discussed that exact issue, the issue of formal reconstruction, I basically said the exact opposite. I've never had occasion to use it, formal reconstruction. I don't know anyone who ever has done it, formal reconstruction, and I doubt it could be done properly anyways, because language is ambiguous in ways logical propositions are not, and so on and so forth. So it's hard to know what position Professor Pinker really expects us to embrace to inform our worldview. Is it the working notion that formal logic, all the way to formal logical reconstruction, is useful and well worth cultivating? Or should we live by the idea that formal logic is pretty useless for day-to-day reasoning? My personal view, again, is the second. Formal logic is pretty useless for day-to-day reasoning. But this is only to say that, well, so is geometry a lot of the time, and so is quantum theory, and so is specific knowledge of the chronology and causes of World War II. However, in all cases there is useful information, and sometimes some of that will come to bear on your day-to-day reasoning. And the thing here is that in those cases, it's rather about how we can go about bringing it to bear, that knowledge, in terms of criticisms or refutations of the other ideas we have. It all depends on what the problem situation is at the time. People go through their life encountering and trying to solve problems, and there will come a time, now and again, a problem that they will find, not often, but now and again, for which formal logic might just help. A knowledge of formal logic, that is. But just because now and again it happens doesn't mean that you should devote hours and hours and hours devoted to figuring out how to understand formal logic better, because it's the rare exception to the rule that it will ever be applicable in your day-to-day life, unless you're a logician, unless you have fun solving formal logic problems. Okay, that's enough of an introduction. Let's get into some reading, and let's begin at the beginning of chapter 4, titled Probability and Randomness. And Pinker begins with a quote. The quote is from Samuel Johnson and says, quote, "1,000 stories which the ignorant tell and believe die away at once when the computist takes them in his gripe." End quote. And we're going to pick it up right at the beginning of the book then after that quote. And I'm going to be nitpicky here just for the first couple of paragraphs, because Pinker begins with, Quote, though Albert Einstein never said most of the things he supposedly said, he did say in several variations, I shall never believe that God plays dice with the world, end quote. And he was absolutely right. Einstein was absolutely right. God does not play dice with the universe. Quantum theory is not a theory of randomness, of the metaphorical dice rolling in the universe, playing dice with the universe. It's not probabilistic at all. Einstein, had he known it, would have embraced. We would think, we shouldn't speak for him, but if someone is committed to determinism, then they would embrace this idea of unitary quantum theory, as I'm more often calling it now. In other words, the multiverse. Let's keep going. So Pinker continues to write, quote, whether or not he was right about the subatomic world, the world we live in certainly looks like a game of dice with unpredictability at every scale. End quote. Okay, I've just got to pick up Pinker on that as well. So he's saying that the universe looks unpredictable. However, what do we say here? That's a form of empiricism. Stars look cold. Stars look closer than they are, and stars look dim. Of course, anyone who argues for the reality of probability on the basis that the world looks like a game of dice is just invoking empiricism. So that's not a very good argument. Let's keep going. Pinker goes on to write, the race is not always to the swift, nor the battle to the strong, nor the bread to the wise, nor favour to those of skill, but time and chance happen to them all. An essential part of rationality is dealing with randomness in our lives and uncertainty in our knowledge. End quote. Yes, so absolutely I can agree with this. We need to be able to deal with uncertainty in our lives. But uncertainty is not the same as randomness. We're not dealing with randomness. We're dealing with subjective unpredictability. And see my episode 111 about probability for that. Subjective unpredictability is you don't know personally what's going to happen in the future. But that's not to say that it's entirely random. Okay, it's governed by the laws of physics. These are different things. Uncertainty, likewise, is just the inability for you to be rationally, absolutely dogmatically sure that some particular thing that you happen to know is the once and for all final truth. Okay, the next section is titled, What is Randomness? Where does it come from? And I'm not going to read through all of this part. He goes through discussing a Dilbert cartoon, and I can't put it up. I think it's copyrighted. But basically, in the first panel, you've got Dilbert being shown around hell, I think, by a demon, and the demon is pointing over into one direction and saying, "Over here we have our random number generator," and the random number generator is a demon sitting there just spouting the words 999, so just saying 999 over again. Dilbert is saying, are you sure that's random? And the demon showing him around hell is saying, that's the problem with randomness. You can never be sure. So quite right too. What Pinker says on this is, quote, this answer captures the second sense of randomness, an anarchic, unpredictable generating process. The troll, the demon, is correct that a random process can generate a seemingly non-random pattern, at least for a while, for 6 digits worth of output in this case. After all, if there's no rhyme or reason to the generator, what's to stop it from producing 6 nines or any other non-random pattern, at least occasionally? End quote. So we should just linger on that because we're doing a close reading of the book. So let's really focus on this because I think it's quite right. As I said in my introduction to this, randomness, literal physical randomness, would mean that something is happening for no rhyme or reason, as Pinker says right there. Okay, so I'm just lingering on that. I think that that's quite right. Actual randomness are events that happen for no rhyme or reason. No cause, nothing prior, nothing determines it. It just happens. There's no reason. And as a consequence, we describe that situation as it's random. And I think this is what people mean. Like kids today use the word, oh, that's so random. And I think that, it means that that's a crazy thing or whatever. But, pushed to explain what you mean by random, it's a thing that happens for no reason. If there's a reason for it, it's not really random. You would appeal to the reason for saying why that particular thing happened. And so if we start to say, well, these random things for which we have a reason for which they happen, then we need a new word for those events that, in theory, in a fictional world, would happen for literally no reason. Okay, so I'm getting hung up on this. So we kind of have 2 senses of random, is all I'm saying there. I'm skipping a part, and I'll pick it up where Pinker says, after he talks more about randomness, quote, all this raises the question of what kinds of physical mechanism can generate random events. Einstein notwithstanding, most physicists believe there is, irreducible randomness in the subatomic realm of quantum mechanics, like the decay of an atomic nucleus or the emission of a photon when an electron jumps from one energy state to another, end quote. Okay, so my issue here is there's a few logical fallacies in what I just read. So he says Einstein notwithstanding, so he's kind of implying that Einstein is wrong, but that's just a mere assertion. We're not told why. He's also appealing to the authority of physicists, because if physicists, never mind physics itself, but if physicists are saying that a certain thing is the case, then it's the case. But also he's appealing to the majority. Okay, so appealing to the majority of physicists. So I think these are logical fallacies. As we like to say, this is not randomness of the previous kind anyway. He's kind of having a bet both ways. I'll come back to that. It's either the no rhyme or reason thing, or it's being caused by physical laws. Well, which is it? Okay, if they're both random, well, then we're conflating two things. Things caused by laws of physics and things that happen for no rhyme or reason. They can't both be random. Or if they can, well, then we've got two quite separate meanings of random. So just to linger on that, like Pinker goes on. Okay, quote, he says, "It's possible for this quantum uncertainty to be amplified to scales that impinge on our lives. When I was a research assistant in an animal behaviour lab, the refrigerator-sized microcomputers of the day were too slow to generate random-looking numbers in real time, and my supervisor had invented a gadget with a capsule filled with a radioactive isotope and a teensy-weensy Geiger counter that detected the intermittent particle spray and tripped a switch that fed a pigeon," end quote. And so what I would say on that is this is subjective unpredictability, as I say. It's not randomness. The former, subjective unpredictability, is a consequence of the laws of quantum mechanics. It's determined by them. But the latter, okay, this randomness, as Pinker himself only just admitted, happens for no reason. It certainly cannot be determined by the laws of physics. That would be the opposite, wouldn't it? Pinker himself, therefore, is not clear on what randomness is because he's switching without concern between things caused, or in other words, things determined by physical laws, and the opposite of that claim, things that happen for no rhyme or reason. Now, in day-to-day life, maybe this is not so much a problem to conflate these things, but in a book on rationality, one would presume one is striving for consistency. In fact, a big deal that, or Pinker makes a big deal of that in various places throughout the book. So skipping just a little bit, and Pinker goes on to say, "How could randomness arise in a world of billiard balls obeying Newton's equations? As the 1970s poster proclaimed, satirising billboards about the speed limit, gravity. It isn't just a good idea, it's the law. In theory, couldn't the demon imagined by Pierre-Simon Laplace in 1814, who knew the position and momentum of every particle in the universe, plug them into equations for the laws of physics and predict the future perfectly? In reality, there are two ways in which a law-governed world can generate events that, for all intents and purposes, are random," end quote. "For all intents and purposes are random," says Professor Pinker. Well, now it seems to me we're switching to a third kind of randomness almost. We can't seem to get it straight. First, random meant, in the book, in the chapter on probability and randomness, random meant for no rhyme or reason. Then random meant something that was actually literally caused by physical events, determined by the decay of atoms themselves, governed by the laws of physics. And here now, well, here we have a randomness that is random for all intents and purposes. So it's a third kind. Like, is it random or not? Oh, for all intents and purposes it is. What does that mean? Not random, right? I don't know. I'm confused. Pinker goes on. I'm skipping some more, and I'll pick it up where he writes, "The other way in which a deterministic system can appear to be random from a human vantage point also has a familiar name. The coin flip. The fate of a tossed coin is not literally random. A skilled magician can flick one, just so to get a head or a tail on demand. But when an outcome depends on a large number of tiny causes that are impractical to keep track of, like the angles and forces that launched the penny and the wind currents buffeting it in midair, it might as well be random," end quote. It might as well be random? Well, the fact is, it isn't. It isn't. So in a book on rationality, when we go to the section on randomness, wouldn't the rational thing be to take seriously reality? So shouldn't we be saying something like, nothing is actually random, but some things seem to an observer to be random, and let's explain why. That would be informative. That would help form a rational worldview because we'd be grounded back in reality. We could consult physics and science and be consistent in our worldview rather than sometimes asserting the reality of randomness or sometimes its unreality but acting as if it's real. Might as well be random, which is what he's saying, might as well be random, is not random. And the difference matters very much because your subjective ignorance, which is a cause of your inability to predict, could make a difference to what you think is possible or not. And that's the real rub. If the world contained literal randomness, or even might as well be randomness, then literally anything follows, or it might as well be that literally anything follows. But we do not live in a world of randomness, or might as well be randomness. We live in a world of unpredictability. But, and big but here,
I like big butts and I cannot lie.
The big but here is that our world is governed by laws of physics that rule out a vast number of things. Not everything is possible. Unlike in a world of genuine randomness, where anything could follow or would follow. There would be no laws, and hence nothing could be ruled out. The next section is titled, What Does Probability Mean? And so we're going to read through parts of this. Pinker writes, quote, when the TV meteorologist says there's a 30% chance of rain in the area tomorrow, what does she mean? Most people are foggy about the answer. Some think it means it will rain in 30% of the area. Others think it will rain 30% of the time. A few think it means that 30% of meteorologists think it will rain. And some think it means it will rain somewhere in the area on 30% of the days in which a prediction like that is made. The last of these is in fact closest to what the meteorologist had in mind. End quote. Okay, so I'm going to reflect on that. Now, this paragraph comes from a paper. There's a note at the end of that paragraph. I went to the note, I went to the reference that is in the note, and it's a psychological study. When I say psychological study, it is what one would expect from a psychological study. It is people have been surveyed. Random people have been surveyed on the street. Supposedly, we're told they're random people. Whatever a random person is. Now, this idea that there's a 30% chance of rain and that some people think it will mean it will rain in 30% of the area. Really? I can't imagine anyone would think that. Others think it will rain 30% of the time. Really? And a few think it will mean that 30% of meteorologists think it will rain. I don't know if any of those are true, but according to the scientific study that is linked to, and that scientific study, I'll link to that in the description to this. The title of the title of that paper published in 2005, easy to find through Googling, is, quote, a 30% chance of rain tomorrow. How does the public understand probabilistic weather forecasts, end quote. So the methodology used in this study was to survey people what they thought the statement meant, and the survey was conducted in Amsterdam, Athens, Berlin, Milan, and New York. And the authors of the study claim that only in New York did a majority give the correct answer. And they say the correct answer is, when the weather conditions are like today, in 3 out of 10 cases there will be at least a trace of rain the next day. Yes, well, that's what the study says is close to what meteorologists mean. I'm not sure, actually, that quite captures it. And their methodology, like I say, was to survey people with open-ended questions as well as multiple choice answers. So if you've got multiple choice answers, you're kind of leading the survey participant, aren't you? So look, again, I could nitpick on this all day. Let's not. Psychology studies like this are extremely dubious, poorly controlled, and well, just poor science, bad explanations. I can still think very few people actually think those false options are true, despite what the paper says, because of how the survey was conducted. I can agree, most people are foggy about the actual answer, but then I think the author of the paper and of this book is foggy about the answer too. And we'd have to ask specific meteorologists to find out what they really think. But in meteorology today, modern meteorology, it's reasonably well known that what is happening, especially these days, is that modelling is done, computer modelling by supercomputers. They're simulating what's going to happen. And when the modelling is done, if 30% of the models with subtly different initial conditions predict rain anywhere in the area, That's why they say there's a 30% chance of rain, because 30% of the models they run, of the simulations they run, produce rain. Here's the thing. Even if you use the same model, the issue is that you can only measure the relevant variables, current, temperature, pressure, wind speed, humidity, and so on, to some precision. Let's say you can measure it to the first decimal place. Well, the problem is that variations in the second decimal place that you can't measure and you don't have access to with your measuring instruments could make all the difference. So those models are getting better over time, but they're still prone to errors, and this is why we have this uncertainty. These dynamical systems are excruciatingly subject to those initial conditions and so on, and because it's a highly complex system, and these days even human beings have some effect on the weather. So what we have is a system that is only partially understood, and so we get sometimes reasonably good predictions. Looking out the window is still a good idea though. And by the way, all this weather talk reminds me of an example. I'm sure I've used this before in ToKCast when it comes to Bayesianism, which we're going to come to in the next chapter. If the person discussing the weather on the news reports a 30% chance of rain, and at 6 a.m. in the morning you're about to walk out the door, you flicked on the television and they say 30% chance of rain today. Do you grab your umbrella on the way out or not? Well, if your umbrella is large, cumbersome, it's a golf type umbrella, and you are taking a crowded train, this decision matters to you. So do you take the umbrella or not? 30% chance of rain. Well, here's the thing. It's a silly question. How about you look out the window? If you just look out the window as the sun rises at 6 a.m. and see a lovely pink gradually clearing to blue sky, that's one thing. But if you see storm clouds and torrential rain on the street, then your 30% guess goes out the window entirely. It's raining right now with a 100% chance, and you take your umbrella. Now, on the other hand, if it is perfectly blue skies, you might not. You especially don't take it if, on looking out the window, you see the clear sky and remember, silly you, when you turned on the television just now, it picked up from where you left off last night when you were watching a week-old interview with the Ukrainian president. And at the end of that interview, they cut to the weather, and so the weather report you were watching wasn't for today at all. It was for last week. But because you were in a hurry, you didn't notice. So forget the umbrella then. And in all of that discussion, notice, I never needed to talk about Bayes, conditional probabilities and so on. I just don't think I'm going through what is called Bayesian reasoning as such. But some people will call it that. I just call it plain old reasoning. I'm guessing and going with my best guess. And I'm refuting guesses along the way when I get evidence that refutes the guess in favour of another better guess. And besides, I wasn't calculating any probability, and this is the whole issue I sometimes have with so-called Bayesians. If you're a Bayesian reasoner, where are your probabilities? Where are your priors? Where are these numbers? I guess we'll have to come back to that. And we will come back to umbrellas and rainy days in sections on Bayes to come in this book. But anyways, that 30% rain, it really means that the model or models say that 30% of the time when they're run, given some set of conditions, they end up producing rain. Okay, I'm skipping a substantial bit where Pinker talks about how probability, what is probability? He's trying to answer that question. It could be the classical definition of probability he talks about. So in other words, this is what I call the a priori idea that, if a dice has 6 sides, then each side, when you roll it, has a 1 in 6 chance of coming up. Now, of course, that assumes a perfectly fair dice, which assumes perfect construction of the dice, no bias towards any side and no bias in the throwing of it, and laws of physics that don't possibly bias it and introduce more unpredictability that I spoke about last time. Like, what if it lands on an edge, or the vanishingly small chance it shatters when you roll it, or does something more bizarre still? Those things are still physics. They're part of reality, and the probability calculus has nothing whatsoever to say about them. So in terms of explaining reality, again, it fails. Pinker goes through the subjectivist interpretation, talks about how that's all about quantifying your belief. I agree that that's what it's supposed to be. So probability is just about how confident you are in things on that particular view. He mentions a few other interpretations and, of course, gets to the frequentist interpretation. And, well, let's read what he has to say about this. Quote, "Finally, there is the frequentist interpretation. If you did toss the die many times, say 1,000, and counted the outcomes, you'd find that the result was even in around 500 of the tosses, or half of them," end quote. So let me just say that again, because I'm going to come back to this again and again. And it's just a function of, well, to some extent it's a function of being a critical rationalist maybe. This nitpickiness. I'm not always nitpicky, but in a book on rationality, when you're purporting to be perfectly rational, I sort of have a high expectation of consistency. And so here, what Pinker has just said. You've rolled a die 1,000 times. You've counted the outcomes. And you find that the result was even in around 500 of the tosses. So maybe 498. And what Pinker then goes on to say is, or half of them. So I think you can guess what I'm going to say. Why is about 500 out of 1,000 half? Why in a book on rationality would we accept 498 out of 1,000 as being equal to a half? And how far away from 500 do we have to get before it's not equal to a half? This is not a good standard for rationality. We're either equal to a half or we're not equal to a half, but this is the way in which we can massage reality so that it appears to obey the probability calculus when we start to just ignore facts of the matter. If the result was that exactly 500 of the tosses all the time were even, if that really was the case, then we could say it was a half. But it's not. It's not exactly equal to a half. It's only approximately a half, which is not a half. Pinker goes on to say that the interpretations of probability are normally aligned, but they're not. Okay, so this is also an issue. Okay, they're approximately aligned sometimes. He then says, in the case of a coin toss, the penny is symmetrical. Again, no, it's not. It's approximately symmetrical. An ideal coin rendered in a computer simulation might be symmetrical. And by symmetrical, I mean perfectly symmetrical, which is what is required for a perfectly fair coin. One among many things that's required for a perfectly fair coin so that the probability calculus would hold. Okay, skipping quite a bit, picking it up where Pinker writes, quote, people also confuse probability in the Frequentist sense with propensity. Gerd Gigerenzer, who happens to be the guy that wrote the paper about what people think when the meteorologist says that there's a 30% chance of rain. Anyway, this guy recounts a tour of an aerospace factory in which the guide told the visitors that its Ariane rockets had a 99.6% security factor. They were standing in front of a poster depicting the 94 rockets and their histories, 8 of which crashed or blew up. When Gigerenzer asked how a rocket with a 99.6% security factor could fail almost 9% of the time, the guide explained that the factor was calculated from the reliabilities of the individual parts, and the failures were the result of human error. Of course, what we ultimately care about is how often the rocket slips the surly bonds of Earth or buys the farm, regardless of the causes. So the only probability that matters is the overall frequency. By the same misunderstanding, people sometimes wonder why a popular candidate, who is miles ahead in the polls, is given only a 60% chance of winning the election, when nothing but a last-minute shocker could derail him. The answer is that the probability estimate takes into account last-minute shockers. End quote. My reflection on this, what I think about all of that, this 99.6 security factor thing that the rocket has, but in fact 9% of them are failing, and the candidate who's given a particular chance of winning an election who actually ends up going on to lose it. What this all means really is that probability, like its cousin, or its brother, or its twin brother, statistics, probability, they can be used to mislead. So not only isn't it about anything physical probability, but as those examples there that Pinker uses himself, as they show, it is used to deceive rather often, deliberately, or at least pull the wool over one's eyes. I think the lesson here is that when someone, expert or otherwise, comes to you with a probability claim, be especially critical. Turn your critical faculties right up to maximum. Be on your guard. Are they claiming to possess knowledge they do not have? Well, that's one thing. Are they using so-called legitimate numbers collected using reliable methods, but then passing that data through a processing system that actually hides what is far more clearly accurate when put in plain language, like was only revealed in these situations upon the questioning? That politics one is a nice case in point. If Hillary Clinton had an 80% chance of winning, well, what are we really saying? And why aren't we saying what we are really saying? Why are the elite pretending everyone knows what we are really saying? What we're really saying? What we're really saying is, it remains anyone's election and we have simply no clue until the votes are counted. So why are we saying that so-and-so has an 80% chance of winning? Why is the media invested in that kind of thing? They don't know. They're pretending to know. The next section is titled Probability versus Availability. And I won't be reading the entire thing. I'll be reading little snippets here and there. And the first one is, quote, People judge the probability of events by the ease with which instances come to mind, a habit Tversky and Kahneman called the availability heuristic. We use the ranking from our brain's search engine, the images, anecdotes and mental videos it coughs up, as our best guess of the probabilities, end quote. And what I'd say about here, what I'd say about that is, in other words, what we know can cause us to think things about what we know compared to what we don't know, which is a statement of logic. Now, I'm not going to spend a huge amount of time on this section in the chapter because it's largely about people overestimating certain dangers, for example, and underestimating others, because the overestimated ones are the ones that are seen in the media more often. So, yeah, that's common sense. I find it not particularly insightful. Doesn't everyone know this? In our worldview, this Popperian worldview and this optimistic David Deutsch worldview that I'm sometimes animated in trying to convey to people, I, personally, take away from that a concern, if I'm going to be concerned about anything, about problems we don't yet know about, the unknown. I agree that there is this issue about people over-egging, so to speak, certain problems. And the biggest problem with that, with the over-egging, with emphasizing certain problems as being catastrophically huge and all-encompassing and that should devote almost all of our attention to, the problem with that is that it takes resources away from simply producing more wealth and preparing the world for the unknown, for the next problem. I really think this is the thing we should be focused on. Pinker, of course, is more concerned about known problems and how people are ignorant of some problems that are known to knowledgeable people, the elites and so on. And he thinks that the learned people know things that the layperson don't know, and the layperson should try harder to fix their ignorance on certain points. And I just think that we're all infinitely ignorant, and we better watch out, because while focusing on, what's beneath our feet, the asteroid is coming from behind us, the metaphorical asteroid, so to speak. And we need to turn around. We need to accumulate more and more. We need to generate more and more wealth, more and more knowledge. That takes resources, so on and so forth. A big theme here at ToKCast. But let's go on. We'll move very swiftly through this section. I'm skipping a vast amount of it, the majority. And I'll pick it up where Pinker speaks about nuclear power. And he writes, quote, "Nuclear power is the safest form of energy humanity has ever used. Mining accidents, hydroelectric dam failures, natural gas explosions, and oil train crashes all kill people, sometimes in large numbers, and smoke from burning coal kills them in enormous numbers, more than 500,000 per year. Yet nuclear power has stalled for decades in the United States and is being pushed back in Europe, often replaced by dirty and dangerous coal. In large part, the opposition is driven by memories of 3 accidents. 3 Mile Island in 1979, which killed no one. Fukushima in 2011, which killed 1 worker years later. The other deaths were caused by the tsunami and from a panicked evacuation. And the Soviet bungled Chernobyl in 1986, which killed 31 in the accident and perhaps several thousand from cancer, around the same number killed by coal emissions every day." End quote. Yes, so that's all worth reflecting on. Now, I would say the lesson there is just don't let things that the media has a fixation on, an obsession with, or that the environmentalists have an obsession with, and politicians and political leaders who become fearful of, don't let all of that get in the way of progress. The lesson here, I would think, is to use cheap energy so that we can generate more wealth and more knowledge more quickly, so that we can come up with, fusion power, for example. To power the knowledge economy, we should do that as efficiently and quickly as possible, because fusion is a physical possibility. We know that. We just don't know the engineering of how to get there. But once we do get there, this is all a moot point. It really is. A glass of water out of the ocean is going to be able to power, entire cities, that sort of thing. So again, the lesson here is with nuclear power, don't be terrified of the distant problem. If people being scared into action rather than rationally acting and choosing, then I would submit that that's part of the problem. Don't scare people into doing things. Allow them to understand the facts as they are, fully, completely. But with nuclear power, it appears, and especially in Australia, we don't have nuclear power. We have huge reserves of uranium. No nuclear power stations. Why not? Well, because people became terrified of nuclear energy. They acted and chose and made decisions irrationally. Politics and morality all went haywire on this. And so it went around the world as well. And now the panic is not so much the nuclear power, the panic is climate change. But why should we expect that the outcome this time around from fomenting fear and terror will work any better than it did with nuclear power? I don't think it will. That's the lesson. Don't create an electorate, a populace, and young people terrified of any given problem. Problems are soluble. Let's keep going. We'll skip another section, and of course, what comes up? Quote, terrorism, like other losses of life, with malice, aforethought, brews up a different chemistry of fear. Body counting data scientists are often perplexed at the way that highly publicised but low casualty killings can lead to epical societal reactions. The worst terror attack in history by far was 9/11, and it claimed 3,000 lives. In most bad years, the United States suffers a few dozen terrorist deaths, a rounding error in the tally of homicides and accidents. The annual toll is lower, for example, than the number of people killed by lightning, bee stings, or drowning in bathtubs. Yet 9/11 led to the creation of a new federal department, massive surveillance of citizens and hardening of public facilities, and 2 wars which killed more than twice as many Americans as the number who died in 2001, together with hundreds of thousands of Iraqis and Afghanis. End quote. Well, this is frustrating. Now, this is one of these areas where you read it and you just go, well, that's not the pinnacle of rationality. We are right to be concerned. And I wonder what Sam Harris would say about something like this, his friend, Steven Pinker, writing in these terms. That's all the wrong frame. Body count is not the metric. And again, frequency is not probability. This is about knowledge and bad ideas. It is absolutely, rightly, the concern of the United States and others that after 9/11 and even before, a real, genuine concern was, could any of these often state-sponsored terrorists get hold of a nuclear weapon? Now, we don't need to hear about the fact that states have hold of nuclear weapons. Okay, there are systems in place, there are traditions, there are worries about these things, but it's a real concern. If a terrorist of the kind who could do something like 9/11 or blow up people on the tube or just stab people in a park or a cafe, if those people have access to nuclear weapons and can get access to nuclear weapons, or even just the material used in nuclear weapons, make a so-called dirty bomb, that is catastrophic. That needs to be guarded against. It has nothing to do with the number of people that are killed each year. And the number of people killed each year, can we consider the explanation as to why that number is small? Is it because we're doing something about it, because of that infrastructure that kind of was written about rather snidely there? This whole idea that the creation of a new federal department, massive surveillance of citizens and hardening of public facilities. Now, I don't like a massive surveillance of citizens or 2 big wars and so on and so forth. But as for these systems being put in place, could they be a reason why the frequency of these things is not far worse? Why the terrorist attack hasn't come? Because it's been thwarted, and we know of thwarted terrorist attacks. In a book like this, one would hope that we would have some statistics, the frequency with which the terrorist attacks have been thwarted, how many lives have been saved. Well, Pinker doesn't write about that, which I think is an important omission. But there it is, terrorism. It always comes up in this stuff. And I mentioned it in my last episode on probability, about risk and so on. The academics love, and the journalists love, chastising the layperson on this point. Saying things like, don't you know how rare it is? You're more likely to get killed by a falling ladder, hit by lightning, something like that. As if ideas don't matter, as if motivation doesn't matter, as if there's not a whole bunch of people out there that might not be capable of committing a terrorist atrocity, but actually support it, because there are people that believe certain things. Sam Harris has talked about this. There are people who commit terror because of the bad ideas that they hold, and there are people who just support those who commit terror because of the bad ideas that they hold. And they're teaching their children right now about all the reasons why terrorism is good, and that's the issue. It doesn't have anything to do with probability and frequency. What it has to do with is the content and effects of bad ideas. And so terrorism is an existential threat. This is one of the ones that I think we have to be as concerned about. If you're concerned about climate change, you should be as or more concerned with terrorism. Because it's immediate, okay? It's happening now. But of course, this is unfortunately politicised. Skipping a significant amount more. This is a long chapter, this one, long chapter. I'll pick it up just where Pinker says, quote, outrages cannot become public without media coverage. It was in the aftermath of the main explosion that the term yellow journalism came into common usage. Even when journalists don't whip readers into a jingoistic lather, intemperate public reactions are a built-in hazard. I believe journalists have not given enough thought to the way that media coverage can activate our cognitive biases and distort our understandings. End quote. Now, I've kind of been saying this recently, that public intellectuals and scientists, at least online, at times absolutely resemble the journalists in terms of their emotional reactions to stuff and the way they conduct themselves rudely. And I've been on my hobby horse about this. These things, these emotional reactions, distort our understanding as much as anything that appears in the media. Because on social media, these people are looked to as representatives of intellectual culture. And if they're carrying on hurling expletives with one another, well, that's an issue. Whenever you see a sports person, a footballer, or whenever you hear about a sports person or a footballer, caught by police for a drunken fight in a bar on some Friday night, there's absolute uproar in the media that this person is supposed to be a role model to youngsters. So courts should throw the books, we're told, at such people for their poor example. But if society has that attitude, what are the consequences for the public intellectual who online enters into a flame war with their own followers using expletives and generally bringing academia into disrepute? Are they not role models as well? They're not so similarly chastised. And this thing about journalists, well, let me just read on. Pinker goes on to write, quote, the press is an availability machine. It serves up anecdotes which feed our impression of what's common in a way that is guaranteed to mislead. Since news is what happens, not what does not happen, the denominator in the fraction corresponding to the true probability of an event, all the opportunities for the event to occur, including those in which it doesn't, is invisible, leaving us in the dark about how prevalent something really is, end quote. So, and Pinker goes on in this vein. I mean, it's somewhat true. It depends on how and to what extent one consumes the news, I suppose. Yes, there is an issue with the media focusing on this and not that. But I think to Western society's credit, we are becoming more cynical about the news. Like, surveys are conducted and they now routinely show that journalists in general, but, especially from CNN and Fox News and so on, they're among the least trusted entities and institutions in society. Some might think this is bad. I think there's a good side to this because it means that people are more often error checking where they can. They're checking multiple sources. Now, they may be falling into other errors, and, certainly some are prone to falling into conspiracy theories. But so long as society is not falling into violent anarchy, and it's not going backwards at all, so far as I can tell. If there is one step back, there is still two steps forward. And if society's going in the direction, as many people bemoan, in the direction of populism, well, I'm happy about that. The opposite, as I recently reflected on, the opposite of populism is elitism. I'd rather live under populism. The reason for that is that the common man, the layperson, well, has common sense, hence the term. They aren't systematically making errors of the kind the experts make, and there is something to be said for perhaps appreciating the fact you're not an expert. Experts tend to act or speak in such a way, sometimes, not all of them, there are some important exceptions, but experts can tend to speak in such a way that if they're an expert in one thing, then suddenly they're an expert in N different things, where N has no upper limit. Things like, well, I'm a neurosurgeon, and so they think to themselves, by comparison, everything compared to neurosurgery is easy. So I guess I'm an expert in chemistry and physics and fixing cars as well. Well, not quite, but you get what I'm saying. And I was going to mention journalists, but I'll just read this. I'll just read this section, so I'm skipping a fair bit. And Pinker then says, quote, a special place in journalist hell is reserved for the scribes who in 2021, during the rollout of COVID vaccines, known to have a 95% efficacy rate, wrote stories on the vaccinated people who came down with the disease, by definition not news, since it was always certain there would be some, and guaranteed to scare thousands from this life-saving treatment, end quote. Okay, well that's, it's true in a superficial sense, but the framing there is, I would say, false. It presumes the journalists did know the truth and that journalists know best. But journalists are average, typical people. They just do journalism. If the average person is scared about some people who are vaccinated getting infected, why is the journalist, pardon the pun, why is the journalist immune from that error, from the error that the normal person is making? They're not. It seems to me that to many intellectuals, they hold journalists to an unusually high standard. They have too high an expectation of the expertise of the journalists. I knew myself growing up. I wasn't even out of high school yet, and I realised that journalists knew little about science because they made so many errors so often in science. And I concluded even then, well, imagine all the errors they're making in those areas where I don't have an interest and don't have much knowledge about. If they can write reports even today, you can pick up a newspaper or go online, read something by a journalist, and it could be titled, "Does your food contain chemicals?" Clickbaity stuff like that. Well, if they can write stuff like that, what do you expect their knowledge of vaccines and immunology is? Really? So forget all this holding journalists to a super high standard. They are not and cannot be expected to be experts everywhere and immune from errors that the average person isn't either. Now, the normative thing should be, of course, that they research more before they write a story and care more deeply about what they're writing, the consequences of what they're writing, and error correct along the way. But shouldn't we all know now that so much of modern journalism is there, it exists to sell stuff, to sell advertising space, to get more eyes on stories? That's what it's there for. It's almost a form of entertainment in places, and so that's up to the individual. And in this case, with this vaccine story, where the journalists have apparently written something misleading, where does the real responsibility lie? Does it lie with the journalist for making the fallacious or misleading medical claim? Or does it lie with the reader, who's apparently taking medical advice from journalists over their own doctor? Surely that's an important issue. Now, Pinker goes on to write, quote, "Journalists should put lurid events in context. A killing, a murder, or a plane crash or a shark attack should be accompanied by the annual rate, which takes into account the denominator of the probability, not just the numerator." Well, end quote. Well, perhaps. But it still isn't giving you a probability, actually. It's giving you a frequency, and that might not be your probability of that thing happening to you. Like, does it work the other way? Does it work for car accidents? Car accidents are reported in the media here in Australia relatively frequently. Last time I looked, there was something like 2.2 million global fatalities per year. Is that a lot? I don't know. To me, it seems like a lot, and roads do tend to worry me. But then I don't drive. Because I don't drive, the likelihood of me being involved in a car accident is somewhat less than someone who's driving to work every single day. Now, it's my irrationality, in part, that I get more worried in a car. I'd rather be on an aircraft all day than even in a car for a short trip. Maybe for other reasons, of course. I'm imagining being in business class at least, and a good meal and a window seat flying over the Himalayas. But the fact is that providing frequencies for all these bad events, for what reason? The news is there to report the news. And even if it provides a frequency, that can give people a false impression as well. If you're told, I think I used this in my last episode on probability, if in fact someone was killed by lightning, right, and then the news reports on this, what Pinker wants to also accompany that story is the annual rate. Only 5 people in Australia per year are killed by lightning strikes. So what are we supposed to conclude from that? Having read the story about someone who was just killed by a lightning strike, but then we also read that, well, only 5 people per year are killed by lightning strikes, and there's 20-something million people in Australia, so why worry? So does that mean that, it's going to encourage people to go wandering through thunderstorms, holding umbrellas on top of high hills? Well, so there are swings and roundabouts on these things if we're talking about rationally considering what a journalist should do. Unintended consequences, I think we call all that stuff. Okay, so we're at a section. Next section is called conjunctive, disjunctive, and conditional probabilities. And again, I'm not going to read most of this because, in fact, very little really. Because this section, it deals with high school mathematics. He goes through some high school mathematics. Here in Australia, this stuff about conjunctive, disjunctive, and conditional probabilities is dealt with in our year 8 or year 9, the second and third years of high school anyway. The first thing is conjunctive probability. Let's go through it. Pinker uses other examples. I'll use coin tosses and card cards, drawing cards, because the numbers are easier to follow and people are familiar with these things. I think they are anyway. So the first thing we have to do is we have to assume the probability calculus holds true. So here's a conjunctive probability. What's the chance of flipping a coin and getting it heads? Well, it's a half. But what's the chance of flipping two heads in a row? Well, it's a half times a half. It's a head and a head. Now, when you hear the word and in probability, often it indicates a multiplication is going on. So a half for the first head and a half for the second head. Half times a half is a quarter. That's the chance of throwing two heads in a row. Now, disjunctive is or, and or, the operator or, logical or, and probability or, is a plus. So if you've got, what's the chance of throwing a head or a tail? Well, chance of throwing a head is a half. Chance of throwing a tail is a half. Add them together, you get one, unsurprisingly. And this is what happens when things are independent. But there is such a thing as dependent events. If I say a standard deck of cards is 52 cards, which it is, what's the chance of drawing the ace of spades? Well, it's 1 in 52. What's the chance of drawing a black card? Well, it's 1 in 2. Half of the cards are black and half are white. We're ignoring jokers in this standard deck of cards. Let's say now, conjunctive events, a sequence of events. What if you draw two cards? Well, what's the chance of drawing a black card followed by another black card? Well, it can't be 1 in 2 times 1 in 2. It's not like the coin. And the reason is that if you're drawing a black card and not replacing it, this is the important thing. You draw out one black card and you don't replace it. What's the chance of drawing the next black card? Well, although for the first card it absolutely is 1 in 2, once you've removed that card, once you've removed the card, then the deck you've got left in front of you only has 51 cards in it. So if you put the one that you've just drawn aside, consider how many black cards are left. Well, it's certainly not exactly half of the deck anymore. Half of the original deck was 26 cards, but you removed one of them and it was a black card, so now you're down to 25 black cards and 26 red cards. So the chance of drawing a black card the second time around is 25 out of 51 because you've got 25 black cards and the total number of cards is 25 plus 26. So your chance has been reduced. It's slightly less than a half now. Now, this is where I want to go back to. We want to go back to earlier on when we're discussing the book. This chance of 25 out of 51, well, that's slightly less than a half. But Pinker said earlier on, didn't he, that being close to a half is a half. So I don't know what he'd say about this. No, I do. Of course, he gets this. The chance of two black cards is, first card, 1 in 2. Second card, 25 out of 51. Multiply those together, 1 over 2 times 25 over 51, and you get 25 over 102. Now, the thing is, if that was interesting to you at all, you can go right down the rabbit hole on this. We get into a whole area of mathematics called permutations and combinations. It's something more broadly at university called combinatorics, which is fun and simultaneously it's also a nightmare. I liked it, but only after lots of practice, which was difficult. But once you get through it, like lots of things in mathematics, it can kind of become fun. It's like a game. Here in Australia, you can actually do some of this stuff in high school. We get to the harder stuff in like year 11 and 12, which I taught for a while. And well, it's just a lot to keep juggled in your head at times. The fun stuff was working out things like how they determine lottery odds, for example. Like if a lottery draw has 40 numbers to select from and you get to pick, well, you have to pick 6 numbers accurately in order to win the lottery. But let's say you are allowed to pick up to 8, you can pick 8 numbers. What's the chance that out of your 8 numbers, you'll get 6 right out of the 40 that you can select from? Well, you can work it out using permutations, combinations. And what about, is the chance any different if you pick 7 numbers, not 8 numbers, or 10 numbers, not 8 numbers, that kind of thing. So anyway, the chapter goes on and we encounter Donald Trump again before we get to the end of the chapter. Well, let's just read the passage. It says, I'll just quote it. Another howler in calculating conjunctions had a cameo in the bizarre attempt by Donald Trump and his supporters to overturn the results of the 2020 presidential election based on baseless claims of voter fraud. End quote. Well, I don't know. Was it all baseless? I don't know. I don't know enough about the situation. But I thought most people, right and left, agreed, rightly or wrongly, that the number of votes involved in this thing was insufficient, ultimately speaking, to change the outcome of the election. But as for baseless claims of voter fraud, look, again, I don't know, but I can say this. I think broadly in the West, our systems are robust, but they're not perfect. Here in Australia, we have something called the AEC, the Australian Electoral Commission, which I was surprised to learn the United States actually lacks anything like this. The USA has this system where each state, or is it district or something, some local authority anyway, takes care of federal voting and how the voting is actually how the votes are counted. So there are different rules in different jurisdictions over there in the United States. That seems ripe for things going wrong. But here in Australia, we have this centralised agency, which is, in theory, stands apart from the government. Okay, so that's fraught with other problems. But it seems to work. This one government agency, which I don't mind the government taking care of that. If the government's going to exist, why not have an agency that just takes care of the counting? Because also in this system of counting, and I think this happens around the world as well, there are also independent observers. Citizens can elect to be observers, or the parties can nominate people who work for the party to go and observe. And in fact, I've done that once. And truth be told, I did it for the Greens Party. I watched the AEC, the Australian Electoral Commission, actually count the votes to see that it was all above board and you have people from all the different parties there. And so I've done this observing of the counting back when I was younger, much younger, more ignorant, less cynical. Anyway, however, I think in every election, and my understanding is in every election, there are some attempts at fraud in the elections. And I think there's some non-zero number every single year, every single election that you have, that are successful. I think it's rare that it would sway the election, but it happens. So I don't think these things are baseless. I mean, here in Australia, the problem is, like with the USA, postal voting. Who is posting those votes and why? Once again, if you get fixated on Trump, as he crops up again and again in this book. Anyway, the Trump stuff goes on for a few more pages. I'm not going to read through it. Pinker explains some more things in this chapter about the gambler's fallacy, all quite reasonable. No run of luck, the gambler's fallacy, ever makes it more likely the luck will continue or not continue. That's the inverse gambler's fallacy, I suppose. And we end on conditional probability. That's where I'm going to end it today, on conditional probability. I'll linger on this because it will be important for Bayesian reasoning. So let's read this section. Quote, Pinker writes, "Finally, we get to conditional probability. The probability of A given B, written as," and I'll put it up on the screen, it's written as probability of A conditional on B. A conditional probability is conceptually simple. It's just the probability of the then in an if-then. It's also arithmetically simple. It's just the probability of A and B divided by the probability of B. End quote. Just keep that in mind. It's just the probability of A and B divided by the probability of B. Let's keep going. Nonetheless, it's the source of endless confusions, blunders, and paradoxes in reasoning about probability, starting with the hapless fellow in the XKCD cartoon on the following page. I'll put that on the screen. His error lies in confusing the simple probability or base rate of lightning deaths, the probability of being struck by lightning, with the conditional probability of a lightning death, given that one is outside during an electrical storm, probability struck by lightning, outside in storm. So the picture there shows we see a lightning crack, but the people didn't get hit by lightning. And one of them saying, whoa, we should get inside. And the other one saying, it's okay, lightning only kills about 45 Americans a year, so the chance of dying are only 1 in 7 million. Let's go on, which was my point earlier. Okay, let's keep on reading. Quote, "Though the arithmetic of a conditional probability is simple, it's unintuitive until we make it concrete and visualizable." And I'm not going to go through the visualization. Instead, I'm going to skip to a specific example, which is what Pinker uses. Quote, he says, "The Greys have 2 children. The elder is a girl. Knowing this, what is the probability that both are girls? Let's translate the question into a conditional probability, namely the probability that the first is a girl and the second is a girl given the first is a girl. Or, in fancy notation, probability first equals girl and second equals girl, on the condition the first equals a girl. The formula tells us to divide the conjunction, which we can calculate to be 0.25, in other words, a half times a half, by the simple probability for the second child, 0.5. And we get 0.5, okay? 0.25 divided by 0.5 is 0.5. Or thinking classically and concretely, girl, girl divided by the possibility of girl, girl and girl, boy equals 1/2. And then skipping a little, and he goes on to have another example. He says, consider the Whites, yet another two-child family. At least one of them is a girl. What is the probability that both are girls? Namely, the conditional probability of two girls given at least one girl. And he writes, so few people get the answer right that statisticians call it the boy or girl paradox. People tend to say 0.5, but the correct answer is 0.33. In this case, concrete thinking can lead to the wrong answer. People visualize an elder girl, realize she could have either a younger sister or a younger brother, and figure that the sister is one possibility out of these two. They forget that there's another way of having at least one girl. She could be the younger of the two. Enumerating the possibilities properly, we get the possibility of girl divided by girl plus boy girl. I'll put this on the screen, which equals 1/3. Because using the formula, we divide 0.25 by 0.75. And the reason why we have that denominator is because they're the possibilities of at least one girl. So you've got to add them all together. Now, this is another, it's again in what high school mathematics is a combination. It's part of permutations and combinations. In fact, what we're going to end on is the very last section is called prior and post-hoc probabilities. But as we'll see, I don't think this is really about probabilities at all. Well, not much of the chapter is. He later calls it a priori and a posteriori judgments, which I think is probably closer to the mark. The confusion here, what he's talking about, is sometimes called the Texas sharpshooter fallacy, after the marksman who fires a bullet into the side of a barn and then paints the bullseye around the hole. So we know about this phenomena. He then goes on to write, quote, if you take note of the predictions by a psychic that are borne out by events but don't divide the total number of predictions, correct and incorrect, you can get any probability you want. As Francis Bacon noted in 1620, such is the way of all superstitions, whether in astrology, dreams, omens, or divine judgments. Or financial markets. An unscrupulous investment advisor with a 100,000-person mailing list sends a newsletter to half the list predicting the market will rise and a version to the other half predicting it will fall. At the end of every quarter, he discards the names of the people to whom he sent the wrong prediction and repeats the process with the remainder. After 2 years, he signs up the 1,562 recipients who are amazed at his track record of predicting the market 8 quarters in a row. Though this scam is illegal if carried out knowingly, when it's carried out naively, it's the lifeblood of the finance industry. Traders are lightning quick at snapping up bargains, so very few stock pickers can outperform a mindless basket of securities. One exception was Bill Miller, anointed by CNN Money in 2006 as the greatest money manager of our time, for beating the S&P 500 stock market index 15 years in a row. How impressive is that? One might think that if a manager is equally likely to outperform or underperform the index in any year, the odds of that happening by chance are just 1 in 32,768, or 2 to the power of 15. But Miller was singled out after his amazing streak had unfolded. As the physicist Len Molodno pointed out in The Drunkard's Walk, How Randomness Rules Our Lives, the country has more than 6,000 fund managers, and modern mutual funds have been around for about 40 years. So the chance that some fund manager had a 15-year winning streak sometime over those 40 years is not at all unlikely. It's 3 and 4. That's a great little story. I like that one. Skipping a bit, and then Pinker writes about an interesting coincidence. He writes, quote, when I was a child, what we now call memes were circulated in comic books and popular magazines. One that made the rounds was a list of incredible similarities between Abraham Lincoln and John F. Kennedy. Honest Abe and JFK were both elected to Congress in 46 and to the presidency in 60. Both were shot in the head in the presence of their wives on a Friday. Lincoln had a secretary named Kennedy. Kennedy had a secretary named Lincoln. Both were succeeded by Johnsons, who were born in 08. Their assassins were both born in 39 and had 3 names, which add up to 15 letters. John Wilkes Booth ran from a theatre and was caught in a warehouse. Lee Harvey Oswald ran from a warehouse and was caught in a theatre. What do these eerie parallels tell us? With all due respect to Dr. Young, absolutely nothing, other than that coincidences happen more often than our statistically untutored minds appreciate. Not to mention the fact that when spooky coincidences are noticed, they tend to get embellished. Lincoln didn't have a secretary named Kennedy, while pesky non-coincidences, like the different days, months and years of their birth and death, are ignored. Skipping a little, Pinker goes on to write, one kind of post hoc probability illusion is so common that it has its own name, the cluster illusion. We're good at spotting tightly packed collections of things or events because they are often part of a single happening. A barking dog that won't shut up, a weather system that drenches a city for several days, a burglar on a spree who robs several stores in a block. But not all clusters have a root cause. Indeed, most of them don't. End quote. Yeah, I'll just mention one here in Australia. A few years ago in Queensland, in a place called Toowong, years ago, there was a cancer cluster at an ABC building. ABC is our Australian Broadcasting Corporation, so the equivalent of the BBC. And lots of people got, I think 15 ultimately, in this rather small building, 15 of the women there developed breast cancer. Given the prevalence of cancer, however, we sometimes, in a big nation like Australia, we sometimes have to expect that at least in one building somewhere, there'll be a cluster. There'll be a lot of people just there by chance for independent reasons, unrelated to the building altogether. It could be related to the building, but statisticians were the first ones to sort of say, well, this should be expected once in a while. They still investigated, but I think that they ultimately didn't find anything wrong with the building. It wasn't like the building was causing the cancer cluster. Pinker uses another interesting cluster. This is from Tversky and Kahneman, and mathematics teachers around the world use this all the time, which is, can you tell the difference between a random series of coin flips and a non-random series of coin flips? And so the experiment that's done, and I might have talked about this at some point during ToKCast. Anyway, the experiment that's done by math teachers is when kids are learning this stuff for the first time, you give one kid a coin and you tell him to go outside the room with his friend and to flip the coin and record whether it comes heads or tails. Okay, so that's one situation. And then you take another kid and a friend and you send them outside and you get them to write down a made-up series of random heads and tails. So heads, tails, heads, tails, heads, tails. And then you get the kids to come back in and to swap the pieces of paper. You can in fact have the whole class to do this. And as the teacher, you can then pick which ones are made up and which ones are actually the result of actual coin tosses. And it's very easy to do. And how do you do it? What's the solution to the magic trick? Well, the solution to the magic trick is the real coin tosses. If you do enough of them, usually 100 is what you say to the kid, do 100 coin tosses. What will happen is that you get these long strings of tails, 5, 6, 7 in a row of tails. That will happen over the course of 100. But the person who's making up the heads and tails, if they don't know anything else, they won't do long strings. They'll do head, tail, head, tail, 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 head, tail, that sort of thing. So it's obviously a fabrication. So you can pick the fabricated one from the genuinely random one, because the genuinely random one has these long strings of coincidences. Yeah, so Pinker mentions that as well. All right, I'm going to end it on that today because we've been talking for a long time, but we're basically at the end of the chapter anyway. We've got misuses of statistics, and hence we've got misuses of probability. And, well, you just rarely need the probability, it seems to be becoming more and more obvious. As I like to say, if you want to know the future, well, tough luck. You don't know the future. That's the first thing to say. If you have a good explanation, well, then it will tell you what will happen, and it might tell you why you can't know the future. But absent any of that, you simply don't know. Now, if you want to know how worried you should be, because, well, the asteroids are rare but cancer is not, fair enough. Take steps. Don't smoke. Smoking causes cancer. It doesn't matter what the frequency is. Smoking causes cancer. We know that. But you personally cannot do anything about the asteroid except maybe send a donation to NASA's project which detects them. So go to my last episode about risk for worrying about all that stuff. But I would just say live your life and enjoy the fact that tomorrow is inherently unpredictable, because it might just be your lucky day. That was a joke. Until next time. Bye-bye.